bundle branch block and hypertrophy. Okay. How many bundles we have? 2. 2. So right bundle and left bundle, and again the left bundle divides to anterior branch and the posterior branch. Criteria of block of anterior branch and posterior branch are there. I'm not going to discuss it now. I don't like to confuse. So simple right and simple left. Is that all right? Good photo. Huh? Okay. How the electricity runs from the right atrium to the left atrium to the ventricles. So SA node generates the impulse, which is going to circuit in right atrium and go to the left atrium as well to make an excitation in left atrium at the same time with a very tiny timing between of them. Where it go? How it goes to the ventricles? Through the AV node. We do not have any other pathway to deliver the electricity from atrium to ventricle except the AV node. All are like a barrier. Okay. AV node is going to let the excitation to be trapped there for a while, allowing the blood to come down, and then it goes to the bundle branch to make an excitation in ventricles. Okay. So initially it goes to the main branch with the AV bundle, and then goes to the either left or right branch, and from there to the Purkinje fibers and excitation of other ventricle. It is how the electricity runs quickly in a heart to understand. So if I speak about left or right bundle branch block, we speak about a blockage somewhere in this branch or in that branch. So we like to discuss the right bundle branch block. So the impulse first activates septum from the left to right, then activates the left ventricle and finally right ventricle. How it going to be? Don't worry about it, I'm going to explain. We have a block here. So the impulse comes from this way. Where it goes? To the left one. So the left branch, this is the septum. This whole septum. Can you see it? This right ventricle, this left ventricle, this whole septum, and this bundle runs in the septums. One at the next to the left ventricle and one left next to the right ventricle. So the right one is blocked, whatever the reason is, but the excitation goes through the left one. So how the other septum is going to be activated? So by direct from that branch to the septum. So it's not going through here. It goes through the septum. So we expect septum to give us a wave, isn't it? Good. Okay. After that, impulse goes to the left ventricle, and from there goes to the right ventricle, because that is not working anymore. Do you understand? So I will repeat it again. The block is here. Excitation waves comes through that one, and to transfer the excitation to the septum, so the impulses goes or travels through the septum from here, so septal excitation, then the impulse goes to the left ventricle and then to right ventricle. So we expect a wave for it, a wave for that, and a wave for that. Simple as this, isn't it? Good. How we can see it? Yes, why QRS? Obviously, why? There is a delay. Usually both branches are going to be activated simultaneously, but not at the time here. So excitation to the left one, after some time the right one. So takes time more than usual. So more than 12. A secondary R wave, we call it some R dash, in V1 or V2. So it could be small r, big S, big R, or whatever. R capital, S capital, R capital, or RS are smaller than ours. But at the end of life, it's M-shaped. The first elevation is the septum. The negative one is the left ventricle, and the second excitation is the right ventricle. Where you can see it, V1 and V2. Why V1 and V2? Because V1 and V2 looks to the septum and right ventricle more than to the left ventricle, so you can see it there. Okay, I told you earlier in V5 and V6 and lateral leads V1 and AVL, we could see Q, R, small s. Small q, R, small s. And I told you earlier that Q represents the septum, and the R is the left ventricle, and the S is the right atrium. So right atrium comes really late, isn't it? So we expected the widening in the QRS. In which part exactly in the QRS? Left ventricular part, septal part, or right ventricular part? Right, because right is the last one to be excited. So supposed to be activated initially with the left, but it's not happening. So it takes time. So what will happen? Wide slab S wave in lead 3, 5, 6, lead 1 and the AVL. I don't know, it's not really okay. Lateral leads. So we'll find that. So the main widening of the complex obviously is right ventricular part, which is S wave in these leads. Let's check it again in an ECG or whatever. Lead 1. You can see here is okay, isn't it? But here is most of the widening is in the S wave, which represents the right ventricle. R, S, R. Q, this is a V6. Q, R, S. Is it more clear? Okay, so two criteria we have for right band branch block. One of them is the M shape of V1, V2, RS, R dash with a component of R dash to be wide. The other one is the slurred or wide S wave in lateral leads, lead 1, AVL, V5, and V6, due to the delay in right ventricular activation. It's okay. Okay. Who can see any abnormalities? Anyone can see any abnormality here?
Even right.
Sorry?
V1 has RSR pattern that RS and then again R.
V1. Yeah. So M shape in V1.
Yeah.
Okay. Have you observed something after the complex? Have you observed something after the complex? Have you observed something abnormal? T wave.
T waves and what?
Which is a normal finding of right ventricular, of right band branch block. So just put in mind, it is one of the criteria, but it's not a diagnostic criteria. That's why I didn't put it initially. So it is a finding of right band branch block, but it's not a criteria of diagnosing right band branch block. Like a finding, you can find. Okay? So it's normal picture. Don't get this. Okay. What more the abnormalities you can see?
Again in B2 there is RSR.
Same way.
Yeah.
Oh.
The
So
T is
RSR.
normal.
Okay.
Yeah.
What else you can see?
Then in B3 the T's become taller. The deflections RS has become less prominent and T's become taller.
Okay. What more regarding the right band branch block?
So that's yeah.
Can you see it? The S wave in lead 1?
Yeah.
In AVL? V5 and V6.
Leads and this.
Okay. The S wave is larger and bigger. Is that alright? Left bundle. Is the right bundle is clinically significant? Yes or no? If you see a right bundle, you're going to be really worried?
It can be physiological.
Could be. That's why We don't get panic when you see red bundle. But if you can put it in a clinical scenario of PE, maybe. But its own can be a normal finding. Many normal ECGs even can see RS or dash pattern, and you can observe it. So it's not that much clinical important, but left does. Okay. So left bundle branch block. Do you understand the principle of right one? It's the same principle, but vice versa. Okay. The impulse active first activates the septum from the right, because left is blocked, from the right to the left, then activate the right, then activate the left. Simple. Another foot. Same excitation, the block is here. Okay? So the impulse comes to the node, then to the right branch, activates the septum in that direction, then goes to the right ventricle, then finally to the left one. And there is no pathway from here. Okay? What do we expect? We expect left ventricle, V5 and V6, isn't it? We agreed that left side V6 actually shows left ventricle. So what you expect? What actually represents what QRS shows? Q is septum, S is left ventricle, and S are ventricle, and S is right ventricle. So Q septum, R is left ventricle, and S is right ventricle. So we expect an issue with the R because it represents the left ventricle. Is that right? Okay. Wide QRS more than 0.12, which is shared knowledge. A broad monophasic R wave that is often notched or slurred in lead 1 by V5 and V6, which is obviously the lateral leads, which is actually looking to the left ventricle as we agreed. So we will find notched R wave, or like an M wave again, but an R wave in V5 and V6. Lead 1 and lead V1 and lead V2 reveals the QS or R S big, small r, then big S pattern with poor R progression from V2 to and V3 and V4. So what we'll find a negative V1, 2, 3 up to 4, then positive 5 and 6 with a large notch in V5 and V6. Okay. Lead 1, the M shape. V1 can be just like a Q, QS together. And V6, you can see that's large one in V6. There's a problem here. If you can see, is a Q wave, which can confuse us with MI, isn't it? Even in left bundle branch block, we can see elevations in AT segment. Is that right? Which confuse us from MI. So it is clinically significant. We need to know if it's really pathological or not. Again, how it looks. QS, tiny r, big S, same way, variable progression, isn't it? No progression, and suddenly we have the S wave, so R wave here and there, which is notched and wide. Clearly. Same way in lead 1, same way in AVR. So generally criteria is M shape, wide complex more than 0.12, and we have M shape in V5 and 6, lead 1 and AVL. And we have a poor R progression in chest leads, including me BQ wave in V1 and V2, which confuse us with the MI because it has also ST. It has ST. differentiating between left band branch block and the MRIs. I'm going to discuss it with the ST because we need initially to have a knowledge about ST elevations, then you can combine both of them. We have some criteria, we call it Scarbosa, and there is a modified Scarbosa. We're going to discuss about modified Scarbosa as well. And I'm going to postpone it to after ST. Okay? To that level, any confusion? I will revise it again. Right band branch block, we expect RS R dash in V1, V2. The first R is septum, the last R is right ventricle, and we expect big or wide S wave in the leads facing the left ventricle, which is V5 and V6, and lead 1 and AVL. Big S, because S here represents the right ventricle, that's why it is white. It is right band branch block. Left band branch block, some criteria can be right axis deviation. It is not a fixed criteria. I'm just focusing on the fixed criteria, but it can have some like 2 of inversions, right axis deviations. Lots of things can be there, but it's not actually the diagnostic criteria of the right band branch block. Left band branch block, again, is M shape in V5 and V6 with white complex, and we have poor R progression in chest leads, starting by V small r or no R in V1, with very poor progression until V4. Confusing us was actually MI. Okay? And studs, again, R wave in lead 1 EVL, you can find it as well. Another criteria can be there, which is the left band branch, left axis deviation can be there. We have seen lots of left bundle with right axis deviation. So it is not a fixed criteria, but it is one of the criteria mostly can be there, including ST segment changes. And but it is not actually the main criteria of diagnosing left bundle. Okay. So right now, sorry for that, I'm going to discuss about hypertrophy. When we speak about horizontal changes, we speak about timing. White QRS complex, band branch block, it delays, it means timing, that's why broad QRS. But if we speak about hypertrophy, it means big chambers and is going to give a strong impulse, which will be reflected as a peaked or high amplitude complexes. We speak about voltage and amplitude. Okay? RVH. What do you expect in RVH? Letters are dropping now. Okay. What do you expect in RVH? Right ventricular hypertrophy. Oh, we are reading. I already put it in. Okay. What do you expect? Okay, leave it. Again, what leads look at right ventricle?
V1, V2.
Okay. So, what actually component of this complex represents the right ventricle? R. Because S is negative. It gives the left ventricular activity, but negative because it is away from the lead. So the only positive here is R, which represents the right ventricle. It's okay. That's why RS R dash will go to V1 in band branch block. So if I hypertrophy happened to right ventricle, what will happen to R? Big one?
Increased.
Big one? Yeah.
Yeah.
So it increases because big chamber, strong chamber is beating more stronger than expected. So it reflects a peak or big wave in the lead recording it. Is that alright? Okay. Again, the criteria as I mentioned earlier, RS ratio in V1 more than 1. It means R, if we divide by S, more than 1, this is abnormal. So normal one, R on S is less than 1. Okay? So R on S ratio in V1 more than 1. Deep S wave in V6. Why deep S wave in V6?
V6 is left ventricle.
Left 6, Q, R, S. I'll review it again. Q, septum. R is left ventricle. S is
Right ventricle.
it was wide in right band branch block. So it would be tall here, or deep, sorry, because it's negative. So it would be deep here. So deep S wave in V6. Right axis deviation, yes. ST segment strain pattern in V1, V3. What does it mean strain pattern? I need you to push big lorry, big car. How much strain are you going to do? How much push are you going to do? Just training. So maybe because of the hypertrophy happens, maybe due to outflow obstruction of the right ventricle, like pulmonary stenosis, pulmonary embolism, whatever the cause is, and the ventricle is pushing against resistance. So, are you going to gym? Are you using gym? No, you have to use gym, no? In gym, we usually use some weight to strengthen our muscle. So we train them and we build up the weight to strengthen the muscle more and more. And the more you do the exercise, the more your muscle gets bigger. Have you seen? Same way as heart does, but there is a law in heart. You can adapt it to resistance until a certain limit, then start to fail. Okay, so within that normal limits, the muscles of the right ventricle can be much bigger or increase size and number, whatever, to usually size, to overcome the resistance the ventricle face. So by time they increase, we call it hypertrophy. You got it? That's why you find a strain pattern. Strain pattern is something like an ST segment, a bit of depression, with some T wave inversion sometimes. We see it most frequently in left ventricular hypertrophy in lateral leads, with hypertensive effect. Same way here as well. When I see ST segment strain pattern in V1 and V3 with chest vein, I get cautious of pulmonary embolism. Right atrial enlargement is not a fixed criteria. Why? Because it is a subsequent or something to be happen after getting the hypertrophy of the right ventricle. So right atrial enlargement, I've spoken about that last session, which is the P pulmonal. Okay. What's the tall B? Tall B. Okay. Can we see this criteria? Yes. Strain pattern. The tall here are wave in V1 and the strain pattern in V1. What is the characteristic of strain pattern to be cautious? The T wave limbs, you know, there is a T wave has two limbs, descending and ascending. You will find one of them obtuse and the other one is acute. And they are not equal to each other. So length is not equal. And the down sloping, as you can see, then acutely come up. It is the picture of strain pattern. And this criteria valid also for the left one. This is a strain how it shows. Okay. So this is a V1, V2, I can expect more tall or wave, V5 and V6, S waves. Okay? What's this? It's not coming, what? I believe I had the one ECG here straight to be sure. I don't know what's running. Okay, forget it. I can't catch it. But it shows the same criteria anyway. Okay, so again, is tall R wave in V1, which is more than the S wave in V1, together with a strain pattern could be there in V1, and we have deep S wave in V5 and V6. Is that okay? The QRS must be less than 0.12 seconds. Why? So diagnosis of right ventricular hypertrophy difficult in presence of right bundle or the WBW, because they are the same. Both of them they have tall R waves. just a hold back, or right bundle which block, they have positive impulse, and here right ventricular hypertrophy again positive. So if it is wide due to whatever reason, it will be difficult for me to tell it is right actually hypertrophy or it is a pathology due to the right bundle branch block or due to WBW. Okay, so must be normal QRS to be confident about the diagnosis. Left ventricle one. Okay. Left ventricle. Which leads look at left ventricle?
5, 6.
Lead 1, which is actually shown from here, and AVL. They usually represent the left ventricle mostly. Okay. And then what you expect if you have hypertrophy in that chamber? The amplitude of the lead represented by this chamber is high. Okay. So if we look at V5 and V6, what wave represents the left ventricle? In V5 and V6, what wave represents R wave?
R wave.
And in V1 and V2, what wave represents the left ventricle? S to negative. V1 here, left ventricle is here, so the negative one is left ventricle. The negative one. So V1 and V2 negative waves are representing the left ventricle. V5 and 6, the positive one is the R wave, representing the left ventricle. Is it okay? Lead 1, R wave, is that right? AVL, R wave, is that right? Good. Just good. So R wave in V5 or V6 plus S wave in V1 or V2, both of them they represent the left ventricle. Isn't it? Because R wave in V5 and 6, they look at left ventricle. And S wave in V1 and V2 represent the, again, left ventricle. So if both of them was the sum of V1, for example, was V6 or V2 was V5, if the sum of one from the lateral, one from the V1 and V2, the sum of them was than 35 small square, we can tell it is left ventricular hypertrophy. Okay? Another criteria. R wave in V5 or V6 more than 26 millimeter, it means 26 small square in V5 and 6 alone. Take care, alone. This criteria is different than criteria. Okay? So if there's another criteria, if V5 or 6 alone more than 26 millimeter or 26 small square, we can tell we have left ventricular hypertrophy. Okay? R wave in EVL more than 11 small square is another criteria. Okay? Stream pattern again in V5 and 6, I have explained it earlier. Left axis deviation is not a diagnostic criteria, but it is a finding. Because left axis can be for any other reason, isn't it? Have we heard about Sokolow-Lewin criteria? I'm going to discuss it. It is a big high. So I need to tell the information about it. And for our stage, our level, more than 5. We are more than 5 noses. We'll repeat again. V1 plus V6 or V2 plus V5 more than 35, not all the complex. S wave here, R wave there, more than 35 small square. EVL alone more than 11, the R wave I mean to say. V5 or 6, the R wave there must be more than 26. So there's all these 3 different criteria to diagnose left ventricular hypertrophy. Another association can be there, which is not diagnostic. This is another criteria, just know it. If you like to know it deeply, that's fine, it's high level, but I need to tell it. Voltage criteria in limb leads, and we have voltage criteria in chest leads. These are different criteria. So limb leads, R wave in lead 1 plus S wave in lead 3 more than 25 millimeter. R wave in lead 1, which represents the positive in lead for left ventricle, and lead 3 sometimes it's documented to be negative. Sometimes I told you plus minus. If it is more than 25 millimeter, we diagnose left ventricular hypertrophy. R wave in AVL more than 11, we have told it earlier. R wave in AVF more than 20 small square. S wave in AVR is a criteria we have not discussed at any stage. I don't know if someone is aware about AVR. It's not in discussion. But S wave, which is the deep one, is the negative. You know, AVR always the negative one. So the S wave always represents the left ventricle. So S wave in AVR more than 14 small square. It is a limb. What's this? Chest leads. R wave in V4, 5 or 6 more than 26. We have told it previously about V5 and V6 more than 26. Again, it is here. R wave in V5 or V6 plus S wave in V1 more than 35. I have told it before. Largest R wave. Can you use a new criteria? Largest R wave in chest leads. Largest R wave wherever the lead is, and the largest S wave wherever the lead is in chest leads more than 45. It is diagnostic. So the first one is V1, V6 together, V2, V5 together. But here we calculate the largest S, largest R. We can add both together. If they are more than 45, it is diagnostic. Okay. Okay. Non-voltage criteria. It means we are not speaking about the voltage of the QRS, something else. It's very important. Increased R wave peak time more than 50 seconds. I will explain it. PR interval finishes, R wave starts, isn't it? It starts until it reaches its peak. If we try to just imagine a perpendicular line comes down to the base, that time here. Did you imagine it? This time is very important. Okay, it's more than 50 seconds or milliseconds in lead V5 or V6. It is. What it represents, to understand, it represents actually the excitation in the whole thickness of the ventricle, the whole thickness of the ventricle. So because this hypertrophied, it is actually thick enough and takes time to the wave to travel across that wall. Do you understand it? And this peak time from the end of the PR segment to the peak of the R wave represent actually the timing of crossing this thickness. So it can represent the hypertrophy. Is it okay? Ischemic depression and tube inversion in left side shift leads, which we call it left stream pattern, which we know it about. So stream pattern is a criteria of the hypertrophy. One good point I need to discuss about the peak time R wave. It's not related to the hypertrophy, but it's a very good tool for you as well, Michael. Is diagnosing or differentiating between VTAC. You can close your eyes if you don't like to listen, okay? Because we didn't discuss it yet, but you can listen. VTAC and STV or SVT or something with abrasion. You know, sometimes you find SVT with abrasion, and you can differentiate it is SVT or VTAC. Isn't it?
Yeah.
This is one of the criteria can establish it. WBW as well. This criteria can establish it. Okay? It is how it looks. So EVL more than 11 alone. V1, we don't usually consider V1 alone, but we need to look at V5. So it is 18 and 23 more than 35. So we can consider a hypertrophy. This is the steering pattern as we agreed. The T wave was that limb, and the other limb of the T wave come upright or a bit acute. Okay. It is how it looks. So if we don't need to find all of this criteria. It is all of the criteria. You can find one or two, whatever, but It's just a collective information to establish diagnosis of left ventricular hypertrophy. So V1, for example, here is not complete one. 1, 2, 3, and this small area can be 4. So 4 it means 20. About 20 small square here, and the V6 is 1, 2, 3, 4, and that one 5. So 25? Yeah, so 25 and 20, 45. So more than 35. If we want to apply the other rule, the longest S wave and the longest R wave more than 45, it applies. If we didn't use the longest, we use that only, and it applies. Okay? Left axis deviation. Lead 2 is negative. Just don't forget this criteria. Must be negative. Okay? I believe EVL also is more than 11. It is a bit tough at the end, but I will just conclude it again. I conclude that bundle branch local initially, so hypertrophy. Right ventricular hypertrophy. Right ventricle V1 and V2. So what we expect? Tall R wave, which is more than the S wave. So R on S is more than 1. Steering pattern can be seen. We can see deep S wave in V5, V6. Yes, because S wave in V5 and 6 represent the right ventricle. Simple as this. You can find right axis deviation. Why not? But it's not criteria. We can find B pulmonal. Yes, but it's not criteria. It is something you can see it. Left ventricular hypertrophy. I will just conclude the simplest way. So V1 plus V6 more than 35 small square, or V2 plus V5 more than 35. I mean to say the S and R, but I'm just getting close. So S and R, and EVL more than 11. These are the most important and famous criteria. Other criteria, if you like to keep in mind, that's something. Okay. The important criteria of having the peak time of the R wave is so good. It's good to know about. So sometimes, because a slim guy can come to you with high voltage ECG, and you can simply tell it is a hypertrophy, and it is a normal variant because he's slim. And you can find the criteria. You can calculate, for example, a 35 small square or more in him. But it is hypertrophy or because he's slim. So we can ask peak time. Check the peak time between the end of BR interval and the peak of the R wave. If it is more than 50 milliseconds, we consider hypertrophy. If not, it's good in that. Also good in VDAC and STVT separation. So any question? It's okay. Okay. The next one.